Have you ever wondered if what you see is what you get? Consider the strange and tragic tale of the Australian jewel beetle. The male of this species is programmed by evolution to find a very specific type of female, one that is large, brown, and dimpled. For millennia, this simple rule worked perfectly. But then, humans came along and littered the Australian outback with stubby beer bottles. These bottles just so happened to be larger, browner, and more enticingly dimpled than any female beetle. The result was a catastrophe. The males became so irresistibly attracted to these glass bottles that they would ignore actual females, attempting to mate with the inanimate objects until they died of exhaustion or were eaten by ants. This bizarre example reveals a profound truth about perception. The jewel beetle's mistake wasn't a random fluke. It was a direct consequence of how its perception was designed. Evolution didn't give the beetle a perfect, objective understanding of what a female is. Instead, it gave it a simple, quick, and usually effective shortcut. Find the big brown dimpled thing. This shortcut was good enough to ensure the survival of the species for countless generations. The problem arose when the environment changed in a way that exploited this very specific perceptual rule. The beetle's senses weren't built to show it the truth of the world, the molecular structure of glass versus a female exoskeleton, but only to guide its behavior in a way that, historically, led to successful reproduction. It's a powerful illustration that perception is not about seeing reality as it truly is. This isn't an isolated incident in the animal kingdom. Think of the herring gull chick. It pecks at a red spot on its parent's beak to signal that it's hungry and wants to be fed. Researchers like Nico Tinbergen discovered they could fool these chicks with a simple prop. A long yellow stick with 3 bold red stripes, something that looks nothing like a real parent's beak to us, was far more effective at getting the chicks to peck. This supernormal stimulus, as it's called, was an exaggerated version of the simple features the chick was programmed to seek. The chick's brain wasn't processing a detailed, accurate image of its parent. It was responding to a very basic set of visual cues. These stories challenge a deeply ingrained assumption we all hold, that our senses have evolved to give us a more accurate picture of the world. We tend to believe that an animal or person who sees reality more truthfully will always have an advantage over one who doesn't. If you see the cliff edge for what it is, you won't walk over it. If you see the predator hiding in the grass, you can escape. This common sense view feels right, but it might be fundamentally wrong. The beetle and the gull suggest that evolution has a very different priority. It doesn't care about truth. It only cares about what works well enough to keep the genetic line going. The central engine of evolution, natural selection, operates on a single, ruthless principle: fitness. Fitness isn't about being the strongest, fastest, or even the smartest. It's purely about reproductive success. How many of your genes get passed on to the next generation? This focus on fitness, rather than accuracy, is the key to understanding why our perceptions might be hiding reality from us. Imagine 2 ancient hominids walking on the savannah. One has a perceptual system that painstakingly reconstructs the objective truth of the world around them, analyzing light wavelengths, molecular structures, and the complex physics of every object. The other has a much simpler system that just gives them a quick, dirty signal. That shape means danger, run, or that color means food, eat. The hominid seeking the truth would be at a massive disadvantage. While they are busy processing the full, objective reality of a saber-toothed tiger, the other hominid has already seen a danger icon, felt a jolt of fear, and run to safety. The truth seeker gets eaten, and their genes for accurate perception die with them. The shortcut taker survives and passes on their genes for a perception that is geared for utility, not veracity. Over millions of years, this process would systematically select against perceptions that are too slow, too complex, or too biologically expensive. Evolution is the ultimate pragmatist. It doesn't pay for information you don't absolutely need to survive and reproduce. A useful illusion will always beat a costly truth. This idea is formalized in what I call the interface theory of perception. It proposes that our senses have not evolved to show us objective reality at all. Instead, they provide us with a simplified, species-specific user interface. This interface hides the immense complexity of the real world and provides us with simple, intuitive tools to interact with it effectively. Just like the beetle's perception was a simple tool for finding mates, our perception of the world is a tool for navigating the challenges of life without being overwhelmed by the sheer data of reality. The goal isn't to create a perfect photograph of the world in our minds, but to give us a dashboard with the right warnings and indicators to guide our behavior. This directly contrasts with the conventional wisdom in neuroscience and philosophy, which often assumes that perception is a process of reconstruction. The old model suggests that our brain takes in sensory data and does its best to build an accurate model of the external world. But evolutionary game theory simulations show that this is unlikely. When you pit truth strategies against payoff strategies in a simulated world, the truth seekers are consistently driven to extinction. This is because the world doesn't reward you for seeing the truth. It rewards you for making the right moves. And making the right moves often requires nothing more than a simple set of symbols that tell you the fitness consequences of your actions. Perhaps the best way to understand the interface theory is to think about the screen you are looking at right now. Your computer's desktop is a perfect analogy for how your perception works. Imagine you have a file you want to delete. You see a little blue icon of a folder on your screen. You drag that icon over to another little icon of a trash can. The icon turns dark and the file disappears. Did you just interact with the reality of your computer? Not in the slightest. The folder icon is not the file itself. It isn't a jumble of silicon circuits, voltages, and magnetic fields stored deep inside the machine. The icon is a helpful fiction, a graphical representation designed to hide that complexity from you. The icon's color, shape, and position on the screen have no relationship to the true state of the file it represents. A blue icon doesn't mean the file is made of something blue. If you move the icon from the left side of the screen to the right, you haven't physically moved the millions of bits that make up the actual file inside the computer's memory. The desktop interface is successful precisely because it does not show you the truth. If you had to toggle individual transistors and manipulate voltages just to delete a file, you would be paralyzed by the complexity. The interface allows you to interact effectively with the machine without needing to be a computer engineer. This is exactly what the interface theory proposes about our senses. The space and time you perceive around you are your desktop. The physical objects you see, a table, a tree, another person, are the icons. An apple, for instance, is an icon that your interface creates. When you see a red round shape, your brain is essentially telling you, this is an icon that, if you interact with it in a certain way, eating, will provide a fitness payoff, nutrition. The apple's redness is not a property of objective reality. It's a feature of your interface, just like the icon on your screen might be blue. The real world, whatever it may be, is hidden behind this curtain of perception. This idea can be unsettling. If you see a train hurtling towards you, that feels intensely real. The theory doesn't suggest that the train isn't real, or that you shouldn't take it seriously. It simply distinguishes between taking something literally and taking it seriously. You don't take the trash can icon on your desktop literally. You know it's not a real can, but you take it very seriously. If you drag your novel manuscript to it, the consequences are real and permanent. Similarly, the train is an icon in your interface, but it's an icon that signals a deadly consequence. Evolution has shaped us to take our icons very, very seriously. Petting the tiger icon has been selected against for a very long time. Accepting that our perceptions are an interface rather than a window onto reality has profound implications for how we understand ourselves and the universe. It suggests that the very foundations of our perceived world, space, time, and physical objects, are not fundamental features of objective reality. Instead, they are properties of the specific user interface that has been evolved for Homo sapiens. Just as a bat's interface is built on echolocation, and a dog's is built on smell, ours is built on a particular set of visual and spatial icons. This doesn't mean the world is an illusion, but that our experience of it is a species-specific construction designed for survival, not for insight into the ultimate nature of things. This perspective, while radical, may help to bridge the gap between our everyday experience and the strange discoveries of modern physics. Quantum mechanics, for instance, tells us that particles don't have definite properties like position until they are measured. It describes entanglement, where two particles can be linked in such a way that measuring one instantly affects the other, even if they are light years apart. These findings completely violate our intuitive, interface-based understanding of separate objects existing in a fixed space and time. If space and time are just features of our interface, it's no wonder that fundamental reality, when we probe it with mathematics and experiments, seems to defy them. Our interface simply wasn't built to comprehend that level of reality. This theory reframes the entire project of science. Science becomes the process of trying to peer behind our own interface. We use mathematics and carefully designed experiments to test the limits of our icons and infer what kind of objective reality could be generating them. The goal is not to simply map what we see, but to understand why our interface is structured the way it is and what deeper reality it might be hiding. It turns our perception itself into a central object of scientific inquiry. We're like users who have only ever known the desktop and are now trying to figure out what a transistor or a logic gate might be. The journey is just beginning. Ultimately, the interface theory invites us to adopt a new kind of humility. The world we see with our eyes and touch with our hands feels like the ultimate reality, the ground truth. But it is likely just one channel, one version of a story, tailored for our specific needs. There may be countless other interfaces used by other conscious agents that are equally valid, yet completely different. Realizing that we are living inside a headset of our own making doesn't diminish the beauty or meaning of our experience. Instead, it opens up the thrilling possibility that the true nature of reality is far more wondrous, strange, and complex than we have ever dared to imagine. It challenges us to look beyond the icons and ask what lies beneath.